Hello, everybody. Good morning. Happy Monday. Welcome to another exciting edition of Move Mondays. Before we get started, as always now, I'll say a little bit about hiring. We're doing it. We're hiring. There are some new faces in the room, and we'll go and introduce ourselves, but there's a lot of new faces in the office today. And the way that you can get hired is aptoslabs.com/careers. We're hiring in BD, engineering, design, across a wide variety of fields that I'm definitely leaving out. But aptoslabs.com/careers is the first step to your Aptos Labs career journey. And you too could be sitting here at this table with us as early as next week. We move pretty darn fast. It's been a week. And during that week, a bunch of things happened. But before we get to what happened this week, let's introduce who's here with us.
Hi, I'm Clay Murphy, and I joined today as a technical writer, along with the fantastic Raj. Spent a decent bit of time at Google, about 14 years, and most recently was at Miston Labs.
Oof. Exciting. Welcome.
Consider this a coup.
Very happy to have you here. I am Max. I do engineering on the ecosystem side.
I'm Al Noki. I'm here to talk about Acania and to ask esoteric Move questions.
Hi, I'm Victor. I work on the Move language and also like VM and like tooling, those kind of stuff.
Hi, I'm Andrew. I work on the Pastor wallet.
I'm Daniel. I'm a production engineer / ecosystem engineer.
Hi, I'm Sherry. I work on building infrastructure.
Hi, I'm David. I like faucets.
Hi, I'm Aline. I put the crypto in cryptocurrency.
Hi, I'm Greg. I answer a lot of questions.
Factually correct. Everything everyone said, factually correct. Not necessarily the whole picture, but definitely factually correct. We had some exciting things this week around gas. That finally went in.
Yes, we finally have our gas. We haven't gotten too many people too angry at us. Definitely make sure if you use a wallet, you upgrade to the latest wallet, because I suspect some wallets are not configured to actually get the right gas use price. The other thing also in that space would be we're always looking for feedback on the existing gas prices for different operations so that we can double check to make sure that they actually are properly tuned. I know there are some surprises in there for you folks, such as the cost of calling a function. I would definitely not recommend you over optimize your code. A lot of these things can be improved both within the VM and the compiler so that we can reduce costs and make sure that the operations are efficient. We haven't actually spent, and Victor can probably elaborate here, but as far as I'm aware, we haven't really historically spent any substantial amount of time optimizing the virtual machine or the compiler.
That's totally true.
Yeah. So great outcome.
Yeah, and also I would say just to emphasize that again, that like the current gas prices are subject to like change. So if you try to do some like over optimization right now, then you may also find yourself like get screwed in the future if we actually like change the gas schedule.
Yeah. And we will try to map the gas schedules closely to the actual cost associated with doing these operations.
And also at the same time, try to make some reasonable manual adjustments to kind of like encourage certain just like well-written code or like pattern.
Yeah. So please give us feedback. Please make sure you're using the latest wallet. The other thing I just want to call out, we did bump up the faucets to appropriately cover the gas prices. But on that note, and maybe Daniel can share a little bit, please stop hammering our freaking faucets. It's actually insane. I've never seen faucets pushing out, I think, 1,000 transactions per second. Very impressed that our faucet can scale that way. I never built it for that purpose. But the faucet is there as a free service. Testnet is intended to be a place for playgrounds. I'd love to actually know why folks want so much test coin. It's not going to be worth anything. It's relatively freely available. The goal is to, we don't really have a strong tokenomics for the testnet. Maybe we should have spent time coming up with tokenomics. Maybe the community will drive the tokenomics. But Daniel, do you want to talk a little bit about what's going on with the faucet and what we're doing to harden it?
Yeah, sure. So I should definitely stress, what David said, that the tokens/coins that you get in Testnet and DevNet don't mean anything to Mainnet. Like, we're not going to be transferring them across or anything like that. So there is no reason to be hoarding Testnet coins. Now, moving forward, it's going to be harder for you to do that because we're going to be launching a new faucet that has much more, I suppose, strongly enforced rate limiting. So we'll be doing a bunch of extra checks and ensuring that, the faucet is being used as intended, which is just for development purposes, getting only as many coins as you need to develop, not to hoard for some reason. So just prepare for that. So if you start seeing, 429 back off codes, that's why.
Back off.
Yeah, back off. And indeed, we will tell you when to back off to. So keep an eye out for that.
But also give us issues, feedback. If you are trying to use the faucet and it's not working effectively for you, we are trying to continuously, mitigate faucet fraud.
The very fair faucet.
Yes, the very fair
The
faucet.
very fair faucet, I like it. Verifiably fair faucet.
That not necessarily true.
No.
We have Eileen here to argue on that point.
Cryptography, fantastic. If anyone is any questions about anything we've said, wants any clarification, please feel free in the stream chat in Twitch. We will be answering questions, and also in Discord. If you go to the dev discussion channel, we will take a look at that during the stream as well. Next up, apparently, there was a release of the.
Oh yes, along with the gas schedule, we released semi-quietly, because I guess we forgot to announce it, the 0.35 through 0.3.5 version of the CLI. This version now does automatic gas estimation for you and handles the fees and gives you a great little thing that asks you whether you want to spend from the lower bound to the upper bound of the estimated amount of gas that it will cost you for this transaction. Additionally, some other cleanups and general wording updates, but that should be a lot more helpful for you to be able to estimate the amount of gas that you would be using for a transaction.
Exciting. Very exciting. Gas estimation is key because gas models keep changing. This is the best way to make sure that you don't accidentally get left with a transaction to spin up gas for. Super exciting. Any other elements of the developer experience that we would like to call out? We have the tap, which is coming and exciting. We have the CLI, we have gas, we did a DevNet release.
And we updated Testnet.
We updated Testnet, and that went smoothly.
Ish. We'd love to know if anybody had noticed anything or any feedback, but always looking to improve and streamline our processes.
Fantastic. Next up, we have Alin, cryptographer extraordinaire. I was struggling to find it. Yeah, cryptographer extraordinaire. My first thought was de jure. That's definitely not true. Cryptographer extraordinaire, man of trees, and all around great guy. So Alin.
Thank you, Max, so much for that beautiful, beautiful introduction. Good. So I was told to talk about some of our cryptography and Move.
Asked.
Sorry?
You were asked.
I was asked, yes. Kindly, very kindly. And I'm happy to do so. However, I would like this to be as interactive as possible. I can always just write this stuff down, and it's no point in me being here if it's not interactive. So please ask questions. Max, you'll recite the questions to me. Yeah, sure. All right, so let's start with some high-level points. So there's a few things I want to say about our Move modules for cryptography. So they've been thought out to provide type safety that helps you prevent subtle cryptographic attacks, like small subgroup attacks or rogue key attacks, and all sorts of other things. So that's a very important element of the API, which some of you might find difficult to use, but just know there's a reason behind this. Cryptography is tough to use in practice securely, and we're trying to prevent everyone from shooting themselves in the foot. Hopefully the API is well documented, but that's for you to judge. Please feel free to tell us if it's not. Another thing in the design is some of these cryptographic operations are very expensive, and sometimes in the move module, we do several of them in sequence and we might fail early on. And when we do fail early on, we charge as little gas as possible. So I tried designing for example, the BLS signature verification API in this way. Since cryptographic operations are probably going to be one of the more expensive things that we charge. And with that being said, there's basically three things in the API at the moment. There's signature verification, and I'll talk about the schemes. There is elliptic curve arithmetic, and there's hash functions. And there's directions for more modules to be added. So in particular, I want to add support for commitments, cryptographic commitments, Peterson commitments. Then I want to add support for zero knowledge range proofs over these Peterson commitments using, for example, bullet proofs. And then I want to add a veiled coin module. Some of you know this as a confidential transaction. This veiled coin module allows you to hide the value of a coin and transfer it to folks without anybody learning how much was transferred. However, the transaction graph, who sent the coin to whom, is still public, but the values remain hidden. So actually, all of this is currently in a PR on GitHub. If you want to take a look over it, I think it's number 3444. I know it because it hasn't been approved for a month. All right. So okay. So and
Your review counts, so please help it across the finish line.
yes. So amongst other future plans are to add more elliptic curves for elliptic curve arithmetic, things like BLS 12381, so you can verify snarks on Aptos. Things like BW6761, so you can do one-layer snark proofs. All of these would be great to do as fast as possible, but currently one of the big challenges I'm facing is to estimate gas costs for these cryptographic primitives. So hopefully, as we improve upon that and can speed up that component, we can add more and more easily. Good. So with that being said, I want to show you some of our modules. And run you through some of the design choices a little bit. So let me try and share my screen. Let's see. Is that visible? Okay, good. And maybe I can remove this. And I don't know the font size. Max, is this a good font size? Should I make it larger?
You can see it.
Make it larger. Yes.
Yeah, make it larger.
Okay.
You can pinch, I think.
Pinch?
I think you can actually just pinch on this.
To zoom, enhance.
No, I don't know. I just want to increase the font size. Oh, that's what you mean. Good. Is this good?
Yeah.
Perfect. So one of the things you'll notice in this module is that we kind of have structs for everything. So we have structs for a public key. But first, let me just start by telling you what this module is. So this module implements BLS signature verification on top of BLS 12381 curves. Now, a really important thing to clarify here is that BLS signatures and BLS curves are completely orthogonal notions. So BLS stands for Bonnet Lin Sachem, that's the signature scheme, and BLS 12381 stands for Barreto Lin Scott, that's an elliptic curve. Okay, it's incredibly confusing because you have BLS signatures over BLS curves. But just so you know, okay, I've been trying to clarify this point a lot lately. Okay, so we have BLS signatures over BLS curves, and we have a lot of structs in this module. A struct for a public key, a struct for a proof of possession, which helps prevent rogue key attacks and multi-signatures. I'll talk about that later. Then a struct for a public key with a verified proof of possession, and then a struct for an aggregate public key with a verified proof of possession. A struct for a signature, and so on. And the reason we do all of this is to kind of, again, prevent yourself from shooting yourself in the foot. So if you want to, for example, verify a multi-signature, you're probably, like most people, completely unaware of rogue key attacks. And if you just go to an API, like verify multi-signature, and here you take a sequence of bytes, and here you take another sequence of bytes, most likely you're going to suscept yourself to a rogue key attack and everything is going to be insecure. So we want to make sure no one does that, and that's why we have type safety structs here. So So let me try and explain the flow here. So you're trying to use verify multi-signature to verify a multi-sig. And you notice, oh, I need to create an aggregate public key with POP struct. Okay, how do I do that? Well, I have to call this function aggregate pub keys, right? Okay, this function takes a vector of public key with POP. How do I do that? Well, I have to call this public key from bytes with POP function, which takes the public key itself, which is a sequence of bytes, but additionally, it takes this proof of possession, which is very important for preventing rogue key attacks. And if the validation goes well, the validation of the proof of possession goes well, this returns a public key with POP, and if it doesn't, it returns none. So now you can take a bunch of these public key with POPs, aggregate them into an aggregate public key with a verified POP, and then verify your multi-sig without being susceptible to rogue key attacks. Max, I'm sure that made perfect sense, right?
For those of us following at home, what is a rogue key attack?
Oh gosh, I don't have slides for that, but a rogue key attack is when you assemble a bunch of public keys into an aggregate public key and verify a multi-signature with it, you might actually include the public key that was adversarially generated. So imagine Max, Greg, and Clay are three people that signed a message together and compute a multi-sig, but Clay is actually malicious.
Sure.
Clay can generate a public key adversarially, so that the signature verifies when he didn't actually sign, roughly speaking. I wish I had slides to show you this in more depth, but maybe we can do that later.
Do that in a different Monday, maybe. Future topics with crypto and Lynn.
Yes. So roughly speaking, the idea is you better be very careful what public keys you aggregate when you verify a multi-sigs, because if some of them are adversarially generated, then your multi-signature verification means nothing. Any more questions, Max?
One of the questions in the chat is public key what? I think maybe we can say that one for later as well.
We'll wait for a clarification on that one. Good. So this was a bit of a mouthful, but it's meant to serve as intuition behind why we have all of these structs and why we have kind of all of this bureaucracy. Really, the reason is exactly what the question is. Like, nobody knows what a rogue key attack is, and nobody should have to worry about what a rogue key attack is if you use this API, right?
Love it.
Okay.
Type safety for the win.
Type safety for the win. Right. So what else is there to be said here about this module in particular? It's rather versatile in the sense that it supports verifying individual signatures on individual messages. It supports verifying multi-signatures. It supports verifying aggregate signatures, which is an aggregation of different signatures on different messages. And because it supports individual signatures, it also supports verifying threshold signatures. So you can do a lot of things with this VLS module.
Actually, I have a question.
Yeah.
So say three people want to co-sign a public entry function. Does one person submit the parameters for the public entry function and then the other people like approve it? Does it go into like a purgatory for those parameters? Where do those go if three people want to sign a transaction with parameters?
I'm not sure if that's a question for me. That's like at the API level, right? Like at the.
Yes, let's change the question a little bit, because this has been on my mind a little bit. So today we have a notion of an off-chain multi-signer for ED25119, but we don't actually have the same authenticator for BLS. Now, which pathway, and this can also be to the general audience, but also from a cryptographic purpose, which pathway feels to make more sense? Should we do aggregation of signatures on-chain where each individual account would have their own BLS account registered on-chain or ED25119, and they would submit their transaction with their proof or their partial signature and then do aggregation on-chain, or should we do aggregation off-chain? So like right now with the multi-signer for ED25119, we have to aggregate a signature off-chain, and then we can submit the transaction to on-chain.
Sure.
But I'm kind of just curious from your perspective, would it be better for folks to instead register their data on-chain, use the on-chain representation for coordination of multi-signer purposes, for multi-signing purposes.
I guess I'm confused about the context. So this module.
I didn't prep you for this question either.
Yeah,
so.
I mean, because I'm not exactly sure I understand what you guys are trying to do. This module will allow you to write smart contracts that take in individual signatures, multi-signatures, aggregate signatures, or even signature shares, and then aggregates them into a multi-signature. And then it'll allow you to verify those signatures in Move. And I believe we kind of depend on this module for our consensus signatures, which are
Yes.
BLS signatures. So this module is also used by our staking, I suppose.
Yeah, so I think one thing we could say to date is, well, we don't have VLS signature for, or support, VLS support for account authenticators.
Right.
One could theoretically create a resource account that is backed, or the signer capability is behind a BLS proof of possession. Sorry, that's probably horribly butchered.
Hold your horse there, David. I don't know about proof of possessions or what you mean by that, but
A signer-based capability using VLS.
Yeah, I don't know what to say. I have to think about exactly what you're trying to say. But we could just add BLS as transaction authenticators. That would be very nice to do. It allows us to do signature aggregation. It will allow us to do threshold signatures, multi-sig wallets very easily.
And maybe that's what the person meant by when public key.
Yes. Okay.
When BLS public key.
When BLS public key. When my pull requests start getting approved, because I'm not writing another one.
I could maybe comment too on what David was saying. I think that the practical context of this is that there are multiple people who control an on-chain parameter, and one person wants to propose a change to that on-chain parameter, and they say, okay, I want to call this function that sets it to 5, and there's a setter that requires a signature.
Sure.
Right, so they submit their sort of proposal, and then that value 5, the question is, where does that value get stored before the other people have signed off on that too? Like, does that assemblage happen on-chain, off-chain? I think is what David was talking about.
The multi-signature aggregation, where does it happen?
It could theoretically happen on
It
chain.
could happen on-chain in Move. You can just do it there, but that would cost you gas. It could also happen off-chain, and then you could send the multi-signature and call the verify multi-signature API that I just showed you here.
Yep.
Right, verify multi-signature. You
Yeah.
just have to construct this aggregate public keys with POP object, which I just walked you through very quickly. And then you construct an aggregate or multi-signature object, which you can do very easily from, I believe, well,
We get the point, we get the point. Point is, this is still very early in its development, and we are looking for people to use this in really clever ways to unlock potential for advanced cryptography inside of them.
I guess that's part of the point, sure.
What is the rest of the point?
You can verify BLS signatures in Move, have fun, write multi-sig wallets, build cool applications, and tell us what other features you need. In particular, I'm very excited about exposing the arithmetic itself of BLS 12381 curves, so that you can do even more fancier things. Yeah. Okay, so if there are no questions on this BLS signature module, I can tell you a little bit more about some of the other modules that that I think might be useful for the community, but we can also move on to somebody else if there's no time.
I think a little bit. There was a question about the coin that you mentioned.
Sure. What's the question?
What is it?
What is it? Okay, so I've baptized this thing as a veiled coin. So it's veiled. You cannot see its value. It has a veil of mystery around it. And it's currently, let me find it here. It's in Move examples. Move, let's just do veiled coin.move. So this is the module. Again, you can open the PR number 3444. I dream about it every night, hoping it'll get approved one day.
Me too.
And everything is there. What is a veiled coin? So let me just restate this. A veiled coin is a coin whose value is not public. Its value is actually stored inside of a Peterson commitment. If you want to know what a Peterson commitment is, I can tell you about it in 20 minutes, but I think you're better off reading about it online and reading our code. But real quickly, a commitment, you should think of it as a sealed envelope. So you take a message and you put it in the sealed envelope. The envelope hides the message, but it also binds you to the message. You can't change what you put in the envelope. So now if I put the value of a coin in this magical envelope, I can potentially do some more magic, cryptography, and split this envelope into two envelopes whose values add up to the original envelope. So now I'm able to transfer my coin to Max and Alnoki, okay? So if I have V in the envelope, I can create two other envelopes with value V1 and V2, prove that V1 plus V2 is equal to V, and give those two coins to Max. And this way, nobody learns how much was transferred, but everybody does learn that I have sent something to Max and sent something to Alnoki. Does that make sense? Does that answer the question at a high level?
Does this, I don't see a dependency on Aptos framework coin, so.
Yes, so actually that should be here, Aptos framework coin here.
Okay, got it.
Yeah, so the way this veiled coin module works is you can take any coin that's registered and kind of veil it into a veiled coin. So you can seal it into an envelope. So that was one of the design choices that I wanted to make sure works, because I think that's rather powerful. You don't have to create a new coin type. You can take any pre-existing coin and hide it. So how do you do that? There is this function here, I suppose. Mint2, is this it? No, private balance. Register mint from coin. So there's this function called mint from coin, which takes any coin of any type and gives you a veiled coin back. There's more bureaucracy to set up this veiled coin module in general, but that's how you can turn any coin into a private coin. Notice that when you do that, everybody knows what you put in the envelope, so you don't get any privacy. The privacy happens later on when you take this envelope and split it into two, giving one to Max and one to Alnoki.
So you hide all of your coins in a resource account, and everyone knows how much you put into the envelope, and then you can split up the envelope. So effectively, you could deposit all your coins to one veiled coin, and then from then on, you could live in a veiled ecosystem of coin transfers.
For sure. So there's this function to clarify what Alnoki said. There's a transfer privately to function, which takes the coin type, the sender and the recipient. So this is what I mean when I say the transaction graph is public. Everybody sees the sender and recipient, but look at the amount. The amount is private. There's a commitment of the amount. So this is that sealed envelope in the Peterson commitment module. Okay, so feel free to look at that and see how it goes. And by the way, the Peterson commitment module uses the Ristretto curve arithmetic module, which is why this elliptic curve APIs can be so important to have inside Move.
So do you have to generate your commitment off-chain based on the value you want to transfer?
Yes, so you have to do that, and even worse or better, depending on how you look at it, you have to compute something called a zero-knowledge range proof that does exactly that convincing that, hey, I have an envelope of value V, and I'm splitting it into something of value V1 plus V2, such that V1 plus V2 is equal to V. Because if you don't, everything's hidden. Like you could make two envelopes, you could have 10 coins that are veiled, and you could split it into two envelopes, one of $1 million and one of $20 million, right? So that would be very dangerous. So this is where a zero knowledge range proof becomes important.
Exciting.
Yeah.
Thank you very much, Alin.
Okay, is that it? Should we talk more, or?
We can come back to it at the end, I think.
Yeah, I'd like to actually have you follow up once we get a little bit more further into the implementation, deployment, and we can actually, have wallets that implement this. So we'll definitely have you in a future call, especially after we get those PRs landed.
Yeah. It's today, hopefully.
No comment.
Fantastic. I also look forward to learning more about it. I think a nice end-to-end use case, like demo basically of the veiled coin, will be super useful for letting people see exactly how it works. And I'm excited to see it too, because it seems really powerful.
Yeah, Andrew, when are we going to get into bringing this to Petro?
I'm excited to work with Alin to see if we can do it.
Amazing.
As soon as that PR is integrated.
As soon as the PR lands, everything is unlocked. Amazing. You heard it here, folks. If you want to help a win, go review his PR. Yes. Next up, we have a surprise guest real quick. Charles is coming over, and I'll let Charles introduce himself. And yeah, hey, Charles.
Hi, everyone. Can you guys hear me and see me?
Yes.
Awesome. Yeah, I'm Charles. I made Aptos name service, which officially joined Aptos Labs like last week. Excited to be here, excited to dig in and build identity on Aptos. Yeah, and if you guys are anyone who wants to integrate, please hit me up.
Fantastic. So I think we had it post this morning.
Yeah, it's live.
It's
real.
live. It's real. Yeah, Aptos name service has joined Aptos Labs. We're working together to deliver a fantastic experience across the whole blockchain for naming, exactly as Charles said. Super excited to have him here, and we'll be releasing.
Could Charles maybe give like a quick 1-minute description of what it is?
Yeah, I think that'd be great.
Yeah, real quick. So I guess V1 or by Mainnet, and on Testnet soon. It's a protocol that lets people buy .apt/.aptos names. It's kind of like domain names, but on the blockchain. And they're also tradable as NFTs. And the goal here is to allow apps and dApps on Aptos to use names instead of addresses. And so like instead of sending money to 0x123 blah, 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 you can just send it to max.apt. So it's critical for UX usability for blockchain. And yeah, that's just the beginning. There's a lot more that goes into identity, but that's where we're starting, and super excited to be on this journey with all of you.
Yeah, and Charles, I hear that a new and improved version is launching very soon as well.
You mean on Testnet?
Hopefully.
So we'll have Testnet ANS live soon, hopefully within a week. And we'll also have docs out that'll let people integrate. Yeah.
Yeah, I'm just really looking forward to not having to type out those massive 64-character addresses and being able to transfer my NFTs via ANS on Testnet.
You haven't memorized your address yet, David?
I go to sleep every night repeating it over and over again, but it just doesn't roll off the tongue and roll into other people's ears very efficiently. I found other accounts are apparently storing all my NFTs.
There you go.
It's very disappointing when you see all those really, really awesome, Aptos monkeys and the Pacas and all those other great things. Raw bears, they're all in accounts that look very similar to mine.
That's true. It's true. But with David, that APT, everyone will know which one you support. I look forward to seeing which one you buy. I'm excited for some of them. I don't know if we want to be shielding around projects, but I will say that I am excited to see the NFTs that we have already being built on Aptos. I think it's amazing, and a lot of them are absolutely adorable, and I look forward to getting one.
Thanks for upping the bar there, man.
Oh, fantastic.
Alex, did you have a question for?
Yeah. Does ANS have a land grab deterrence system?
Yeah.
No, kidding.
Yeah, it will. We can talk about that. But basically, the goal is to get names into the hands of real users who will actually use them. We want to minimize squatting. We want to prevent fraud and abuse and stuff like that. But yeah, we can talk about our plans internally. We'll have something out soon, hopefully, that will explain all of it.
Cool.
Yeah, it's probably a good idea to pause on the questions on ANS today. We haven't really gotten, Charles just started, so he hasn't had a chance to kind of wrap his mind around all the things that he's going to be trying to bring together for Testnet and Mainnet. So I'd love to have him on a future call where we can actually dig into all the really cool things that are coming to ANS. So we'll announce that when that's available.
Yeah, and it is coming soon. Thank you very much, Charles. Super exciting news. Super excited to see where we go. Next up, Econia.
Yeah.
Fantastic move questions, and now.
Yeah, I'm Al Noki from Acadia, the core developer. I'm here to talk about Acadia because otherwise I would ask too many questions. And Acadia is an on-chain order book for Aptos. It's built from the ground up around the Move programming language, and it's optimized to use the parallelism that is intrinsic to Aptos to settle as many transactions as possible across multiple markets at the same time. It even allows for parallelism within markets, has O1 lookups for deletions, and those can be parallelized against other things like insertions across markets as well. And so Acadia has grown and evolved over the course of DevNet and the pre-mainnet days with our other integrators. We've been integrating different paradigms that allow for things like margin trading. We support generic assets, which enables derivatives. We are already on version 3, which we have been live on DevNet with. The first version of Acadia went live on July 17th, and we've been shipping iterations since with the community. Acadia is a purely back-end system, and so any front ends that are started to build up are on top of Acadia. And so the idea is that similar to a Robinhood account or a Charles Schwab account that is built on top of an underlying stock exchange like the NASDAQ, Acadia is that underlying settlement layer that everyone else is building on top of. So if someone routes an order through a protocol like Aries Markets or through Hippo, that's going to clear against the same order book as anyone routing through any other order market. And we designed it to be as modular and as composable as possible so that protocols can build for their customers whatever kinds of features they want, because we provide so many that they can just kind of pick and choose. And we've been iterating with the community. We've been open source since inception. We also recently put out a guide called Teach Yourself Move on Aptos. And this is to provide the developer community with the same sort of tutorial and self-teaching sequence that we used when we were getting up to speed on Move. It's got all kinds of references ranging from Aptos documentation to a recent Move prover tutorial that Zellick put out, for example. And we welcome all feedback on the protocol. Our docs are at acadia.dev, and they lay everything out for anyone to understand. We've got all the API docs for the different Move functionalities. We've got auto-generated markdown files that talk about every module we have that include things like dependency diagrams and the like. And like I said, we've been iterating with the community, and we've been building it in the image of anyone who wants to build on top. So for example, our delegated custody paradigm is something we designed with Aries Markets that made it easier for them to build margin trading on top. And similarly, the generic asset support that we're enabling, that we're building out for that we already built out for V3, enables derivatives that other people have been asking about building on top of Acadia. We've got standalone swaps that lets anyone route any coin against any book without actually even needing a market count. It's just a public function library called coins going on one side of the trade, they come out on the other. And we've brought that same kind of modular composability paradigm to the traditional sort of market order experience. So limit orders have all the typical restrictions like fill or abort, post or abort, immediate or cancel. And market orders have min base, max base, min quote, max quote, and a limit price, which allows for integrations that combine AMM pools with an order book DEX. And the closest example I can refer to would be Radium or Atrix on Solana. So we already have integrators who have not yet announced, but they are building this kind of solution on top of Acadia that will allow retail to passively provide liquidity on markets while merging that with the professional market maker liquidity that we are providing additional support for through our high performance APIs. And so moving forward, we are building out our V4. As we say to some of our potential partners, the real alpha is on the V4 branch. And that is going to be optimized, but not over optimized for the new gas schedule for deployment on mainnet. And we are planning to roll out with a multi-signature controlled address so that no one person or authority owns Acadia and can shut it down, but so that it is maintained by the community who approves parameter updates, like I was just discussing with David and Aline. And so we are going to be launching with that on mainnet when we finalize our V4 and go through audit, which we're already working with a couple of partners on. And we look forward to taking all community feedback and integrating it into Acadia to make the most user-friendly trading experience.
Amazing.
And I can take questions too if anyone has any, but I don't know if they do. So I'm just excuse me for that.
Super exciting. I think the fact that the code is completely open source is amazing. Thank you for building from the start. You've been asking fantastic questions that really show that you've been really diving very deep into Move. And so I think that there is a huge amount to learn, let alone the fact that you built a very performant platform for everyone to actually use as well. So thank you for both, I guess, contributions, not only to every Move Monday, but the ecosystem as a whole.
Thank you for having me. Optimistic concurrency for the win.
But yeah, if anyone has any questions for him, just a reminder, you can put them you can put them into the chat in Twitch, or you can put them into the dev discussion channel, and we'll be happy to answer them.
So I think one question I'm kind of curious, you've been in this space for a while now. You're on, I think, your third iteration of Iconia.
V3 has been released. V4 is in development.
How do you envision the upgradeability story for Iconia? Are you going to be creating parallel order books, or are you going to just be upgrading the existing one and then bringing people into the new goods? Like, what's your general process here?
So right now, our move.toml file, as people may see on GitHub, includes the compatible publication policy, which means that we can ship Iconia version 4 on mainnet. And then if we have non-breaking changes, we can then republish as version 4.1, 4.2, right? And so the idea is that these changes can be audited and they will be published by the multi-signature consortium that I alluded to earlier, so that it has that there is not even the possibility for someone to do a rug pull if they wanted to, that this is the kind of process that will be vetted by the consortium of signatories to the Iconia address. And so this allows us to add compatibility. And so that means that old order books won't be affected because you can't change the struct type in Move, for example. So those will be set, but it'll just potentially have more APIs and then potentially new structs, right, that can add additional functionality. As far as, a potential breaking change much later down the road, that's always a possibility, but we wouldn't want to force anyone onto it or just kind of break things. So you can see the closest metaphor might be Uniswap V1, V2, V3, right? For Iconia, we will launch our V4 on mainnet. And then in the future, we could potentially do a V5, but our plan is to do purely compatible upgrades so that we can support all the liquidity that's on the DEX and all the user experience that people have gotten used to over time. And I'll just note too that with all these different iterations we've been doing in DevNet, we do this out of the luxury of being able to in the pre-mainnet phase, and we are going to be more strategic on mainnet with our launch. And I'll just say that because everything is funny money and it resets every Thursday, we have the capacity to do this. But for those who are interested in building on top, yes, we are focused on the developer experience and providing only backwards compatible upgrades.
So then on that note, if you do find that there's new functionality that becomes available, what would be your process to bring that in if it does result in a breaking change?
Mm-hmm. So for potential breaking changes, the most straightforward approach is to basically have a growing sort of feature list of, okay, here's the things that we would like to have. We can't do it in the current version because it's breaking. So then we accumulate those. I mean, kind of like any sort of open source software release, Python says, well, these are nice to have, these are important. This is when it's going to go in version like 3.12 or whatever. Yeah. That will wait to 3.8. And so we envision the same approach for Iconia where, for example, if we can use a parallelizable aggregator on event emissions that will allow us to emit events in parallel, we will not need 6 event handles for ask places, ask cancels, and buy fills. We can just combine those to maker events and taker events, right? Because then you won't need to, because we can parallelize our data structures across event handles, right, but event handles cannot parallelize themselves. So that kind of thing, right? We can work internally on our data structures to modify them, and then always do the traditional open source, feature upgrade list, which is you set it and then you deploy.
So now I'm going to ask a question that's going to just, basically asking for very harsh critical feedback.
Yeah.
So you've been focused on making Icania the hyper performance order book on top of Aptos. You have had no tools to kind of indicate what is a performant way to write move code.
Mm-hmm.
Now that you got the initial gas schedule, I'm sure your head is like, whoa, this doesn't map to my expectations. Can you walk me through some of your early learnings as you've kind of been working in that space, and take it as an opportunity to just drop that feedback on
Yeah.
us?
So with the gas schedule, right, we've been designing as much as we can in the early days around traditional computing paradigms. So make anything that is order of n to be order of log n, or if possible order of 1, decomposing, abstracting, making things modular. And so then when the gas schedule came out, some of our preliminary findings, which we discussed with Robert from OtterSec, for example, an auditor in the space as well, we agreed that some of them were expected, namely the function calls. And there's kind of a loaded question in the teaching about this, which you'll eventually get to. But we can now sort of optimize for, but not over optimize, right, to the gas schedule. And one thing we found is that if the compiler itself can be optimized, that there are opportunities to, for example, upload a bytecode package that is way bigger, but charges less gas when it gets run. So you pay more on the publication. The same way that Aptos CLI, you can locally build a 113 meg one that's fast, or you can download the 13 meg precompiled that's faster to download. In our case, we would rather compile to something that makes one single call on the stack, rather than using nested function calls on the stack in the VM, because it costs more. So we definitely would like to have that input on the compiler optimizations. And we've been integrating some of the feedback we've been having from the core dev team about our underlying data structures. For example, we implemented a binary search tree known as a cryptbit tree that uses a vector of nodes. And now we are up for V4, we're upgrading to what we're calling a crypt queue, which implements a sub queue in each leaf on the tree. And this uses a hash table of nodes for order of 1 lookup. And also because if you were to append to the end of a vector continuously, you would eventually overload it, because the vectors have to store all this serialized blob data on chain. So there's a bit of poking in the dark and Plato's cave that is happening, but it's coming together, and the feedback that we are getting from the team, the core team, is helpful. And obviously any documentation on the gas schedule or anything in general with Aptos is always helpful. We like to write the docs, and we like to read the docs as well.
So that was much more positive than I was anticipating. Thank you for being gentle.
It's always great to hear. Fantastic. Any other questions? We have a couple from our audience.
Yeah, let's take the audience.
Cool. Before we dive in here, in general, tokenomics coming soon, mainnet coming soon. Official date is autumn. Other similar questions also soon. But Austin is great. Agreed. Austin's pretty cool. The official from the comments, the official thing was dude is legend. Just pretty cool. Let's see. WebSockets support. Not planned anytime soon, but we do want to in the future help build out Indexer to be a little bit more of kind of the full indexing flow. And that's not just writing to a database, it's also the whole thing of events and getting filtered events, getting filtered fire hose, all that kind of fun stuff. So that is coming soon, but less soon than I think we'd like, but definitely something that's on our radar, and definitely use cases that want to support internally and for the community as a whole. Let's see. There's also a question about porting things from Solidity and Viper to Move. There is a lot to consider in mind. The model is very, very different. And we've been talking for quite some time about having tutorials, documentation specifically aimed at people who are coming over from, Rust and Solana or Solidity and Viper, to help kind of explain what's similar and what's different. The ownership structure is kind of the biggest thing, in that in Solidity you're using maps for everything, and in Move it moves. The actual NFT moves.
Actually, I'd like to ask Wolfgang a question on this note. Wolfgang, you're the father of Move on EVM. I'm kind of curious if you have a position of what it might look like for Solidity on top of Move VM.
Yeah, so that's an interesting question. So I think that will be difficult. So the value proposition is problematic because the safety which Move gives you via the Move bytecode would be not that easily available if you are in a Solidity EVM-based world. No? Because what you really have to do is simulate an arbitrary linear address space within a Move, and then basically simulate all this kind of data structures which the Solidity has in this similar linear address space. And yeah, so all the safety things wouldn't be there, but it's technically possible, and we can think about doing it. No, but at this point of time, I'm not sure what the advantage would be. A part of like maybe getting some more people on Aptos which would like to own Solidity instead of a Move. Yeah, so that's.
So one thing I'm particularly curious about is with the proxy contract approach, is there a way that we could even implement something like that inside of a Move VM?
What was that, the last thing? What implement what?
Proxy contract approach that happens in Solidity, is that something that could feasibly be implemented inside of a Move VM?
A proxy contract?
Yeah. Like the dynamic dispatch that is available.
This is a good question. So like, that we have some work item to think about this. So first I have to say that what we did for module upgrade is already capturing probably like more than 60–70% of the use cases of proxies in EVM. No? So proxies are often used in EVM to do exactly what module upgrade is doing in Aptos. But we are doing it, I think, in a better way because we can check compatibility. The remaining cases with dynamic dispatch are very interesting, and I think I can't give you a definitive answer like now. So my feeling from a home language viewpoint is, yes, you actually need dynamic dispatch sometimes. There is no way around it, and it's a powerful concept, but also a dangerous concept. And whether we find a way to get that powerful concept into Move without taking the dangerous aspects over is something we still need to explore and figure out.
Well, I am looking forward to the future of Move. Thank you, Wolfgang.
Another question for Wolfgang, actually, on the same topic. Someone heard, I think you mentioned proxy contracts, and is now asking, can you use proxy contracts on Aptos, and how?
Can you, sorry, the acoustic isn't very good. Can you proxy contract on, can you repeat?
Yeah, what does a proxy contract look like on Aptos?
A proxy contract. Well, I mean, we don't really have a proxy contract in Aptos, so it's it looks like nothing, doesn't exist. So what does a proxy contract do? No? So a proxy contract really call into it, and then it basically delegates or forwards your call to some other contract, no? And you don't know to where. So like, so you as a user call into that contract, you have no idea where this is going into some other, maybe good contract, maybe going into some malicious contract. And also, if you know a little bit about home languages, requires actually to be able to generically dispatch and implement these delegate calls in a way where you basically have metapolling or reflection, which is supported in Solidity, another dangerous and powerful concept. So the proxy call, so like I wouldn't even call it proxy. No? So what we really want is like if you know a little bit about Rust, then I think a better thing to think about is we want DIN trade. No? So that is dynamic dispatching, and so this is the feature which is currently not a Move, and that feature allows you potentially to compose, for example, different token or other kind of implementations in a dynamic way. So you can do that composition at runtime. You don't need to compile the thing new if you have a new token implementation to compose it with another component in the system. That's the advantage of dynamic dispatch, and that's where also the relation is to the DIN trait in Rust. No? And we may have something like this at a later point of time, but we wouldn't even call it proxy. So it would have nothing to do with proxies. Proxies is a very technical notion which was developed for the EVM to do this code upgrade thing mostly, I think, and now it's misused for many other things. So that notion isn't really the point. It's really dynamic dispatching what we are talking about.
Point to you raise an interesting point on the upgradability aspect, which is since
We have 1 minute.
okay, since you can actually upgrade a contract, you can change a call that a function is like that function can change what's happening in the body of the function. You could theoretically say, I want to upgrade my function to now call another contract, another module altogether. You can change your dependencies. So it's not a very fast path to proxying, but it does allow through this statically compiled approach.
Fantastic. One last question about someone who's looking to build a dApp on Aptos and query index on-chain data. We have an indexer. I've linked it in the Twitch chats. We're running it internally for our projects, and a couple of other dApps are already using it. We're super open and would love to hear any feedback you have. It is custom built for the Aptos chain, and now it is high performance. It'll get, with the right hardware, it'll get, I don't know, 11K TPS, 11K TPS roughly, sometimes higher. But yeah. And we are at 11. Thank you everyone for coming. Thank you everyone for being here with Move Mondays. We'll be here again, same time, same place next week in increasingly painfully hot Palo Alto.
Increasingly?
I hope not, but it's been hot, man. It's been hot. Thank you everybody. Have a great week and we'll see you again. Bye-bye.